Hello everyone. 大家好. 大家好 means hello everyone in Chinese because this talk will be perhaps potentially for young Chinese. Yes. So today my talk is my hardware, Flying Stone Tiny 01 Revision ShenZhen. ShenZhen is a third city in China, which is famous for computer and electronics. And it is called Gnuk Token. Gnuk Token is a token to store my private key for GNU PG. So this is the FST 01 ShenZhen version, and it is ready now. This part is FST 01 ShenZhen, and this is a metal case. To begin with, I'd like to thank you to Luis Philip Murillo for this opportunity of ShenZhen. He kindly invited to ShenZhen DIY group a few years ago, 6 years ago or so. And that opportunity made this project. And many, my friend Gnuk are related somehow. And lastly, my brother in Hong Kong kindly offer bed and breakfast for me. Yeah, Hong Kong is next to ShenZhen, as you know. Me is a somehow long-time hacker on a GNU project and Linux, and Debian and GNU PG. And I come up an idea for 01 and all for my self-introduction. These days I'm doing 3 projects. One is a Noisy. Noisy is a random number generator, and it is very important for random number generator. Nobody should control on random number generation, so that the random number sequence cannot be controlled by some single engineer or a single company. It is considered very bad. So 0 means nobody, and 1 means independent, individual, or only you. So my project Gnuk is for 1 and only, for your private key. So 1 represents my Gnuk project, and all means GNU project, and it means that everyone deserves computing freedom. So that is my kind of my catch copy of my work, 0, 1, and all. Yes. And this is the first version of FST 01, which I designed in 2011, and it was manufactured in 2012. I used KiCad for PCB design at that time, and I keep using KiCad. But it also offers me problems. So let's go. Why I designed Gnuk Token? At first I made a firmware, but I don't have a good hardware as a reference design. So I have to design myself the reference design of Gnuk. So its purpose is to control our crypto computation for only 1 user. So it is very important to minimize the attack surface. So the goal is, for hardware design, the goal is it should be reproducible by anyone. it is so important. It means that our independence against some manufacturer. So, and all technical documents should be available, and with no NDA, never. This is very important for Gnuk Token. And the other freedom is also important. I don't want to be dependent on some proprietary tool. So I use KiCad for PCB design, and I use GNU toolchains for firmware, building the firmware, and I use OpenOCD to access my hardware. And those practice makes it possible to avoid possible backdoors. And then I may, after some, it was 2011. The first design was 2011. And then I had to design another. This is my use case of Gnuk Token. I use single token with multiple computers. And I have to use, I had to update my design in 2016 because of format change of KiCad. Yes. You know, for reproducibility, format change considers not that good. And, but anyway, I understand it is required. It was required. But and some chip, LDO was discontinued. So anyway, at that time, I need to update my design. And it found that SPI flash in original version of FST01 was not used by anybody. So I removed the SPI flash from the board. And it was designed in 2016, and it was manufactured in 2017. And then, last year, I have another opportunity for new design. That is FST01 ShenZhen, because of, again, format change of KiCad. So perhaps some users of KiCad encounter this issue. So anyway, it is a good opportunity for me to update my design because of major reasons two. One is MCU protection of the. I use STM32F103 for FST01, but these days it is on the service menu for in the advertisement of the reverse engineering company. I mean that it said that we can read out the flash contents of the MCU if requested. So I don't know how much does it cost, or if it is applicable to the particular chip of the FST01. But it is already, and the advertisement is available. So I should change the MCU. Yes, that was one of the major reasons. And another reason is that these days computer chip can be very small. And on the other hand, in the original design, I use a big USB connector. So people can, malicious engineer can put small chip inside this connector to compose chip in the middle attack. So I need to change the form factor more smaller. That was the two reasons, and this is the result. And my challenge is use of Chinese part. The new part, GD32103TB, it is basically pin-compatible version, and newer and faster and cheaper. And I also use the small USB form factor called wristband. It is common, a kind of de facto standard in China. So I take those two Chinese technology, and I also use Chinese test clip and Big Bone Green as a JTAG debugger. So this is an interesting chip by Giga Device, and GD stands for Giga Device, not Godot engine. Yes, the game engine. But it uses licensed ARM Cortex-M3 core, but the peripheral is independent re-implementation of the ST micro. So, and the good thing is that it has no wait cycle to the flash access. Actually, it is static RAM based architecture, and static RAM is loaded by flash content at the boot time. And so the access to SRAM is no wait cycle. It is very good feature for it means that less side channel information. For example, it makes power analysis and timing analysis difficult because of no wait cycle. This is very good feature for cryptography. Yes, and this is a USB form factor called wristband, and it is a kind of de facto standard. It's smaller, and it composed of two parts, metal shell and a board. Originally, it is for small USB memory. Yes, and this is the parts, metal shell and plastic connector. And this is the original wristband for USB memory. So it is called wristband. This is a Chinese character, which means wristband. And these days we have a plastic cover for this form factor. And we have many kinds of the plastic cover, include perhaps this infringes copyright. You may know that's a Spider-Man, perhaps. And we also have a Batman or Doraemon or any in China. Yes, in fact. And we also have a metal case like this. And FST 01 ShenZhen version with metal case it considers have a very good feature against tamper resistant. It has a feature of tamper resistance because it is one-way procedure to put a shell into the case. And this is the photo. FST 01 ShenZhen version in action. This is the metal case, and have a hole for LED. And this is the test environment using the test clip, special test clip, Chinese, made in China. And this is a Big Bone Green. I use Big Bone Green as a JTAG debugger because we can run, I run Debian on this computer so that the SWD flash process can be controlled by all free software. Even if in the factory, an engineer use a computer with Windows, the flash writing process is controlled by Debian. So it has less attack vector than using Windows directly. So this is a close shot. And I'd like to share some of my experience. My purpose is for open hardware is reproducibility for computing freedom. So there are many things for reproducibility. We have a component availability problem, like the LDO is discontinued. So then I have to update my design, or tools data format matters too, as I explain, as I encountered 2 times, and that's okay. That's okay. And tool chain also matters. Like a Gnuk tool chain, it is very important for reproducibility. For reproducibility, if it is intended for many or mass production, we should have a test plan. And it is better for us to publish our test plan together with our open hardware design. That is my proposal. I'd like to propose a practice, this practice, publishing a test plan for hardware design, so that people can reproduce the design and check if it is the same hardware. Yes. And thirdly, China is very important for hardware design, and it's good to learn Chinese culture for better communication if you consider manufacturing in China. And especially the very important thing is holiday season. Now, this week we will have a Chinese New Year. Happy Chinese New Year. In October we have a national day in China, so we should know such a schedule. And it would be good to learn about how Taobao or Alibaba work. It's very good to find a Chinese unique product there. And the personal relationship is, I think, very important in Chinese culture. So I occasionally visit ShenZhen to just say hello. Yes. And it is very important to confirm the exact part, exact material, exact schedule. So to keep good relationship. And in China, specifying manufacturer and manufacturer product number is not enough. Yes, because of say copycat culture. It is somehow difficult to identify original manufacturer, because there is some sort of shared culture in the industry. Say the mold type are shared among the company. Yes, so it's okay if the component is not a Chinese one and available worldwide in Dejiki, Maozhou, or etc. But when it is a Chinese unique part, you should check with your own eyes. Yes, it is my recommendation. Yes, yes. So remember that the copycat culture, but I like it. Re-implementation is good for improvement, and it is a source of innovation. So I'd like to say thank you for this culture, but you should know that. Yes. So ShenZhen is a big city, computer and electronics, many young engineers. But as a Gnuk PC developer, I have some concern because QR code payment is ubiquitous there, and there are so many surveillance cameras and policemen. Yes, so you are a privacy guy, it would be difficult for you to visit ShenZhen. It's wrong, yeah, I won. And to summarize, in 2011, I started. Basically, mainly it was because it's cheap, but things has been changed, evolved a lot. And now in China, they have a good PCBA service, and there are many unique chips and components. And I take advantage of those things in ShenZhen to achieve good product. That's my presentation basically. But here I have some discussion. And here are my questions, 3 questions. How do you maintain your hardware design in your repo? In my case, I put my GABA, the output, because I am not sure the version change of the tool, KiCad, guarantee the same output or not. So I also put the output in the repo, but I'm not sure if it is good practice or not. Usually for software, we avoid putting our output into the repository, but for hardware design, currently, for me, it is inevitable. So I'd like to listen your opinion about that. And how do you ensure the output is same as the authors and yours? So here, that is my concern. Are you using some automation like a CI/CD feature? That is my question. And how do you care about the reproducibility of your hardware design? That is my discussion. And lastly, my children's question. If it is so reproducible, why people buy from you, Papa? Good question. I don't know. But I can say that there is a tribe called hackers. Thank you. That is my... So, questions? Or a comment? Or answer to my question? Yes.
A comment? I think people like to buy the product from the developer because they don't have to risk manufacturing problems or variations, exactly as you say. They know they will get a working product if they buy something tested by you.
Yeah, thank you. Yes. Yeah, thank you. Should I? Should I? Let me repeat the question. No, his comment. People want to support developer, and people care about the distribution problem if there is a man in the middle. So it makes sense to buy from the developer directly. That was his comment, if I understand correctly, right? Thank you.
I have another comment. Is it good to have the software put on the chip by the manufacturer? Because if that's infected, you don't see.
Yes, his comment is that in my term, there is a possibility to infect the malicious software inside the chip. So it makes sense to, if person can believe the developer, it is better to buy directly from the developer. Because there is another possibility of the attack, changing the firmware between the developer and the consumer. Yes, is that right?
Time for two more questions.
Yes.
And then we stop here, but because we're going to be kicked out of the room, but we can discuss how to. Time for two more questions.
So this is maybe a bit related to your previous question and what you mentioned earlier about test plan. So do you already have an idea on how to test that the product you receive is what you intended, and if it's the same that what you basically published?
The question is how a user can test if the hardware is exactly the one developer built. My answer would be yes. I have a kind of test suite in Gnuk distribution, so a user can run that test suite against when he received the hardware. But still, it would be possible. Suppose there is a malicious guy in the channel, in the distribution channel, and he can also run my test suite. So it cannot guarantee there is a malicious code inside. So once I propose some hardware feature so that the MCU can emit the SHA-1 hash or SHA-2 hash of the flash ROM content, but I don't know. I have no idea, and the semiconductor company want to support such a feature in the MCU. So currently, I cannot guarantee, or a user cannot examine for software distribution. You can check by the SHA hash or using the GPG for the digital signature, but for hardware, we don't have yet. That
one
yes.
quick question, one more.
How does your hardware protect the private key? Because when you get the hardware, you can upload a different firmware, extract it, or I see, and into that direction.
So the question is how my technology can protect the private key against several attacks. Yes, the answer is that I depends on the MCU protection feature by the semiconductor company against it is against JTAG direct access. So JTAG direct access is prohibited using that mechanism. So people suppose malicious guy get the hardware, he cannot use JTAG debugger to access flash content. But he can possibly, so when with JTAG debugger, all he can do is clear the flash content. He cannot read out the private key.
Attacks possible to.
Okay, maybe take the discussion outside.
Yeah.
Speaker again.
Yes, thank you. So lastly, I say happy hacking. Thank you.